Approximately 1.25 million years ago, the Earth underwent a severe climate shift. The Middle Pleistocene Transition brought prolonged periods of extreme aridity, stripping away dense arboreal forests and replacing them with vast open steppe deserts. For early hominins, the protective canopy was gone. Homo erectus adapted by transitioning into a fully terrestrial, endurance-adapted generalist, forced to navigate an entirely exposed landscape. Out in the open, they shared the terrain with a highly lethal predator guild. Megafauna, including giant hyenas and saber-toothed cats, heavily outmatched early humans in sheer physical size, speed, and natural weaponry. To avoid becoming prey on the open steppe, Homo erectus had to engineer a multi-layered survival strategy that relied on coordination rather than physical strength. The evolutionary response was encephalization. Homo erectus developed a significantly larger brain, but neural tissue is highly metabolically expensive. It requires a massive, steady intake of calories. Coupling that large brain with the narrow pelvis required for obligate bipedalism created a biological bottleneck. To survive birth, human infants had to be born in a highly altricial or helpless state. We can quantify this using a bioenergetic ledger. Reaching independence requires a human infant to consume an astronomical 10 to 13 million calories. Under predator threat, it is mathematically impossible for a solitary mother to forage enough while defending her infant. Without natural armor or sufficient foraging capacity, human survival required a radical intervention in social organization. The first pillar of this survival matrix was cooperative breeding. To neutralize the biological deficit of helpless infants, early humans evolved a system known as alloparenting. This chart visualizes how extreme intersubjectivity, the cognitive ability to understand and coordinate with the intentions of others, allowed the biological mother to distribute the defensive and caloric load. Grandmothers, older siblings, and unrelated males all absorbed a portion of the infant's requirement. Caregivers practiced near-constant baby wearing in makeshift slings. This regulated the infant's physiology through physical contact, while ensuring the child remained within the group's immediate reach of protection. By offloading the burden of care to the broader group, the mother conserved vital energy, and specialized foragers were freed to seek out the high-yield calories the troop desperately needed. To acquire those dense calories, Homo erectus utilized confrontational scavenging. Rather than hunting large game directly, they engaged in the high-risk tactic of actively stealing rich fats and proteins from apex predators at fresh kill sites. This scatter plot visualizes computer simulation data analyzing Homo erectus scavenging success against the giant hyena. It measures the exact caloric return per capita against the size of the hominin group. The model identifies a hard lower bound failure point. Foraging groups of fewer than 5 hominins were consistently outcompeted or killed by solitary giant hyenas. It also reveals an upper bound failure point. While groups larger than 13 individuals successfully secured the carcass, the caloric payoff was spread too thin. That leaves a distinct evolutionary sweet spot. A group size between 5 and 13 individuals provided the exact balance of defensive force and caloric profitability. Displacing a saber-toothed cat or giant hyena without starving the troop meant these early humans had to operate in highly calculated, optimized unit sizes. Facing down a predator still required intense psychological warfare. Hominins employed aposomatic signaling, coordinated aggressive behavioral displays designed to convince predators that the group was a unified, highly dangerous target. By engaging in synchronous chorusing and rhythmic percussive strikes, they created an intimidating wall of sound that disrupted the predator's focus. The Acheulean handaxe was the vital piece of technology anchoring these percussive displays. Symmetrical, heavy, and sharp across its entire perimeter, it served as both a formidable close-quarters weapon and a high-energy instrument to strike wood and stone. They layered this with the mastery of fire. A burning hearth secured the group's nighttime perimeter, while the smoke was used to dry and preserve the scavenged meat, dramatically extending their caloric runway. By synthesizing precise group coordination, powerful acoustic intimidation, and advanced stone tools, early hominins engineered a behavioral shield. They dominated the top of the food chain without needing to be apex hunters. Look at the bioenergetic ledger now. The 13 million calorie debt is offset by alloparenting. The predatory risk is neutralized by aposematism and Acheulean technology. The raw energy requirement is fulfilled by confrontational scavenging. The equation balances perfectamente. Not all hominins survived the math. Contemporary species like Paranthropus failed to adopt this cooperative matrix and were driven to extinction under intense predation pressure. But the flexibility of this integrated system allowed Homo erectus to thrive. Armed with cooperative defense and shared care, they became the first hominins to break out of the African continent and expand across the varied environments of Eurasia. The requirement for a village to raise a child is a million-year-old bioenergetic reality. This integrated survival strategy is the specific mechanism that prevented human